Welcome to Rules for Adding and Subtracting Numbers that are Scientific Notation. First, before we begin, please take out your notes and copy these rules down. And there are 4 of them. Thank you for taking down these rules. We'll read them right now. When we're adding and subtracting numbers that are in scientific notation, first we convert each number so that all the numbers have the same exponent, so times 10 to the nth. Key is going to use the largest exponent. Always move the decimal to the left. Complete the adding and subtracting and determine sig figs. The only thing that's new for us is, well, nothing. We know what is the largest exponent. We can count. We know how to move a decimal to the left. We know how to add and subtract. And we just learned in our previous lessons how to use significant figures. The thing that is different was putting everything together into one concept. So let's look at an example at this point. Here's our first example. 9.98 times 10 to the 5th plus 5.20 times 10 to the 4th plus 6.25 times 10 to the 9th. Just like we did before, we've got to figure out which one has the largest exponent. So if we do the largest exponent, it's going to be our times 10 to the 9th. Now what we have to do is we stack it. Just like sig figs, we're going to stack. So 9.98 times 10 to the 5th. 5.20 times 10 to the 4th. And 6.25 times 10 to the 9th. So as previously noted, we have times 10 to the 9th being our largest, which means in the rules that we stated earlier, we go back, we have to convert each of these numbers to the largest exponent. And we do that by moving the decimal place to the left, and this will equal out the exponents. So we take times 10 to the 5th, first number, move it over 4, so this becomes the 6th, it's the 7th, it's the 8th, it's the 9th. We add placeholders. Now we have a times 10 to the 9th. Move this one over, so we start with 4, 5, 6, 7, 8, 9. Add our placeholders. It's now times 10 to the 9th. To make this a little bit easier to read, we are going to rewrite it 0.0000998 times 10 to the 9th. Second number, 0.0000520 times 10 to the 9th. And finally, our original number, 6.25 times 10 to the 9th. If we add them up, 0, 10, carry that, that's 10 and 15. Carry that again, that's 0. Carry that, that's 1, 5, 2, and 6. So our number is 6.210500. Large number, and all those numbers are not significant. So we use the same rules as we did before. Sig figs, no number, no number. This doesn't count, no number. Doesn't count, doesn't count, doesn't count, doesn't count. Since that's the last one, we are going to round up, so it becomes 6.25 times 10 to the 9th. I know you're wondering, how is it possible that we just added 3 numbers together but we did not come up with a different answer? Well, that's because the numbers we've used are the 6.25 times 10 to the 9th is so huge. If we actually write it out, it would be 6, 2, 5, and then we'd have to move it over 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9. add the zeros, add the commas. So we're at 6,250,000,000. But when we were adding this, it seemed originally, before we moved decimals, oh, we're adding a 9, a 5, and a 6. So just rough estimating, we're at about 20 or 21. But the exponents are so small, and this is the key thing, it was at 4 and at 5. But those numbers, if we were truly to write them out, (9.98 times 10 to the 5th). We move those over and actually look at the large number, 1, 2, 3, 4, 5. They become 998,000. So 998,000. And the other one's even smaller. It's 5.20 times 10 to the 4th. If we write that, move up here. 1, 2, 3, 4. So it's 52000. So actually looking at the full numbers, we're adding 6,250,000,000 to less than a million, and then just 50,000. So this number is so large that adding these two is insignificant. So that's the key thing. We have to make sure that these exponents are all the same. If not, we're not really adding true numbers. We're just adding 3-digit numbers with some exponents. So let's go over another example. And this one I won't make as large, so it actually will make a significant difference. So we're going to add 9.01 times 10 to the 3rd, 6.11 times 10 to the 2nd, and 1.97 times 10 to the 4th. First, find the largest exponent. That's 4. Now we've got to move each number so they're significantly the same, as n times 10 to the 4th. The first one, we move always to the left, so we're going to move it one spot. Second number, we're going to move 1, 2. Now let's put these with our new decimals, 0.901 times 10 to the 4th, 0.0611 times 10 to the 4th, and the one that does not change is the 1.97 times 10 to the 4th. Adding 1, 2, 13, 10, 19, carry it, becomes 2.9321 times 10 to the 4th. Dual rules. These cancel out. This cancels out. And that is our last sig fig. So it's 3 sig figs. This is our rounder. So it becomes 2.93 times 10 to the 4th. So the number does change. The number does change significantly because we're adding numbers that are very close to each other. So that's 2 examples of adding. Now subtracting is the same thing. There is no difference other than you physically are changing the operation. And the operation instead of adding is subtracting. So follow these rules. If you need to see these again, please review it. That is rules and how to add and subtract numbers that are in scientific notation. Thank you for listening.